going back to what we did on Monday, negative exponents are what? Positive. Remember, we're talking about small positive numbers. Think of like a microscope. Very, very small numbers. And what's the use of it? Why do we have negative exponents? What's the most common use for it? I don't know if I mentioned this the other day, but imagine if something is, imagine this number right here. Right. You say, well, it's kind of difficult to work with that. If you're trying to use this as a calculator or doing a lot of calculations with this and type in 0.0000000000682, kind of a pain in the butt, right? So this whole negative exponent thing came around simply because we really can't do a whole lot of calculations easily. It's easier just to say, well, this is really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Every time you move a decimal, it's like multiplying by 10. So we can rewrite this same number as 8.62 as 10 to the negative 11th. There's your negative exponent, right? It's just a fast way of saying this very, very small number when you're talking about things that are like microscopic or even the atomic level, subatomic level. Quite useful. Alright, so just a little reminder how to multiply binomials. We'll do a little bit of adding, subtracting, multiplying, dividing of binomials. No, excuse me, we'll do adding, subtracting, and multiplying. And then what we're getting into Thursday and Friday is long division with polynomials and synthetic division with polynomials. So today we're doing the review on adding, subtracting, multiplying. Thursday, Friday will be the dividing part. But this was the question that was actually on, those are the questions that were actually on the final that most of you got right anyway. But just in case we need a little review, we can always multiply polynomials this way using an area model or a box model, okay, and then add up the diagonals. And we'll use this a little bit today. And you guys know doing this backwards is called factoring. When you're given this question and you have to come up with the two factors, that's called factoring. So this is just the reverse of what we've been doing a long time. We'll use this a little bit. Alright, so we're going to be add, subtract, and a little bit of multiplying polynomials. Really fast, what is a polynomial? Okay. What can it not have is probably a better way of looking at it. Polynomials cannot have negative exponents. Polynomials cannot have negative exponents. They cannot have square roots either. And they cannot have variables in the denominator. So 3 things. And these are, again, simple questions, right? Is this a polynomial or not? Yes or no? Of course, you could guess, but there are 3 simple things. Just have to know. Negative exponents, square roots, and then, again, variable and denominator. So if it has any of those, it's not a polynomial. It's something similar to, is it a function or not? If it's a polynomial or not, we can do certain things. If it is a polynomial, we can do x, y, and z. If it's not, we can't. So we don't want to assume anything is what it may not be. Alright, so this whole thing, that's a polynomial, doesn't have any of those 3 things. This is a polynomial, doesn't have any of those 3 things. And a lot of this really has to do with square roots of negative numbers. We don't want to Polynomial can't be a square root because we can't plug in negative numbers here. These can't be square roots because we can't plug in zeros here. It just messes everything up. So underlying reason for these three things really has to do with dividing by 0. Alright, so something like this. We've done this plenty of times before. Some of you might see it written like this, where it's stacked vertically like an old-fashioned elementary school problem. You just go like this. So either way you want to do it is fine. Just keep in mind your signs are important. So negative x squared minus x squared is, okay, so negative 1 is negative 2x squared. Negative 3 minus 2x equals negative 5x. 4 minus 5 is negative 1. So if you look only in the columns, it looks wrong. Oh, negative 3 plus 2, that's not negative 5. 4 plus 5, that's not negative 1. So just remember, if it has that negative, you have to remember to distribute it. Distribute the negative. Simple, but important. Alright. Give this one a try, see what you get. Only combine that needs combining. Doesn't mean everything has to combine with something. Sometimes there's like only one squared term, so that's not much to do with that. And yeah, really, this is pretty much as difficult as it's going to get. We're not getting too elaborate. So we got to make sure we know these skills for the long and synthetic division. We'll use all of this. Got to add, we got to multiply, we got to do all that inside synthetic division. Alright, so we get what? 3x squared minus x minus 5? Yeah. And notice how I wrote it in descending order. I put the x squared first, then the x, then the number. Try to do that just as a habit. Highest exponents first, and then count down. Right, no problem. We can do that. Distributive property. Remember, we have to when you're multiplying with two bases, you add the exponents. Not that it matters here, because if you add or multiply, you get the same answer. But when you do here, make sure you add it. You get an x to the third. So this will be x squared. And then do the numbers. 4 times 6 divided by 3 is 8. Of course, you could do the division first. Remember, a fraction just means multiply the top and you divide the bottom by this number. So it's 6 times 4 divided by 3. But you can also do 6 divided by 3 times 4. It's the same answer. So whatever ones are easier. So a fraction just means multiply on the top and divide on the bottom. So 9 divided by 3 is 3. 3 times 3 is, 3 times 4 is 12. And then, like here, if you don't want to do 4 times 12 and get 48 and divide by 3, you can always do 12 divided by 3, which is 4, and 4 times 4 is 16. So sometimes there is an easier way. That's why it's good to know both. So it's always multiplying top, dividing bottom, in any order that's easy. And don't forget your sign. There you go. Alright, so we can do that, we can do that. I'll just, go ahead and give it a shot, just to make sure, verify. You notice when I was showing it, I did all the variables first and then all the numbers. That's the way I prefer to do it. Seems like if I have a rule I have to do 3 times one problem, I'd rather do it all at one time instead of, okay, now exponent rules, okay, now different rules, okay, let's go back to exponent rules, okay, let's go back here, and jumping all around. But whatever, of course, works for you is fine. Okay, so let's see, we probably have a to the third, a to the second, and then second, and then just an a, and then -2, -3 is 6, positive 22, and -40. There we go. Alright, multiplying. So we have to switch gears. Now we're multiplying. You can do distributive property, that's fine. Which means you distribute the x to all of these. Okay. Then you have to distribute the -4. Notice I said -4. So the whole number. Subtraction signs are negative signs, same thing. So that's 6 multiplications, and then combine all like terms. If you prefer, you can use the area model. And that was just when you, like on the warm-up, set it up like a multiplication table in a sense. So you multiply rows and columns and stuff together. Actually, I should be doing that. Here. So you see how we have 6 multiplications this way? There's still 6 multiplications, 6 boxes. So it's not more or less work. It's just whatever you prefer. Whatever gets you the right answer more often. Alright, so we get x squared and x. That would be, what, just 4 and 16. Here we'll get all the variables stay the same. Nice thing about the area model, -16, and -16 times 4 is, how did I get 6? Try that again. 24, carry the 2, 64. Yeah, get 64. Nice thing about the area model is the diagonals are the like terms. We don't have to go searching through that long string of work to see what cancels with each other or what adds together. This is quite interesting that most everything cancels. Your final answer is simply x to the third minus 64. And you guys might remember this as a difference of cubes. So we have a difference of squares, right? Like x squared minus 16. We know that factors to x plus 4 and x minus 4. But we also had a difference of cubes, where we can say, well, if I know it's x cubed minus 4 cubed, the first one is x minus 4, and then x squared plus 4 plus 4 squared, 16. And we'll look at that a little bit more. Make sure we can factor a difference of cubes. Very useful when you're doing the synthetic division. This is like one of those cheats. If you know this, sometimes you don't have to do synthetic division and a lot of work. You just know that. Okay, so either way that works. Either way that works. Yeah. So give it a go. Try it if you want to try distributive property. Do the 6 multiplications, combine like terms, or if you prefer, you can do the area. Just make it into like a box structure, like a multiplication times table. Give that a go, and just watch out for details. This is not so much difficult mathematically as it is you have to write neat and not miss a negative. If you write real small and you can't see the negative you wrote down, of course you'll miss it. So writing neatly or large will help you out. And again, this is about as far as we're going to go, as much as we're going to do. We'll use all this though for synthetic division. Check with someone next to you once you got it, just to make sure we're 100% correct. We didn't miss a negative or miss something small. Right. And when you're ready, also have the answers here from the homework, I believe. So we can check those out as well.